Right, in this video we're going to find the matrix that represents a given rotation in 2 dimensions. Also it works for reflections and enlargements, which we'll look at in a later video. So if you look at what happens to the unit vectors I is 1, 0 and j 0, 1 under a given transformation, gives us a quick way of finding the matrix representing the transformation. Right, in order to do that we need to consider the unit square. So unit square has 0, 0, 1, 0, 1, 1 and 0, 1. Now the points that we're interested in are I and j. What happens to those under the given transformation? So this is a vector 1, 0, and this would be a vector of 0, 1. Now, so we're going to look at a rotation 90 degrees anti-clockwise about 0, 0. So under that transformation, I will go to I dashed and j will go to j dashed. So just pause the video just to think about that for the moment. So I, 1, 0, is mapped onto I dash, and I dash is 0, 1. And then j is mapped onto j dashed, and j dashed is minus 1, 0, the vector minus 1, 0. So these two now form the matrix. What we do, we take them to find the matrix for a rotation 90 degrees anti-clockwise about 0, 0. We take 0, 1 and write down 0, 1 here. And then take the what happens to j minus 1, 0 here, and that gives me the transformation that represents a rotation 90 degrees anti-clockwise about 0, 0. Repeating that for now a rotation of 180 degrees, so 180 degrees, I will move to here and j will move to here if you rotate this shape around 180 degrees about the point 0, 0. So I, 1, 0 is mapped on to minus 1, 0, the vector minus 1, 0, and j is mapped on to the vector 0, minus 1. And therefore we get the rotation, which is minus 1, 0 and 0, minus 1. Finally, let's have a look at a rotation of 270 degrees anti-clockwise about 0, 0. Okay, so the shape's now gone there. So the point I will go all the way around to here, to I dashed, and I dashed is going to be 0, minus 1. And the point j will move round to this point here, which is going to be the point 1, 0. Therefore, putting these together, we're going to get 0, minus 1, the first one for I, and then for j we put 1, 0, and this gives me the matrix. Note that also this gives me the matrix applying for a rotation 90 degrees clockwise about 0. But remember, if we go around that way, the angle is positive. If we go around that way, the angle is negative. So this has been a video to show you how to find the matrix representation of rotations about the origin. In a later video, we'll look at any angle about the origin. I hope you've understood, and I thank you very much for watching.